Now let's look at the common mistakes people make with binary tree code and how to avoid them. Let us look at the most common tree bug. This is a buggy version of preorder. The fixed version is on the next slide. It starts by printing X arrow data. It reads from X straight away. It never checks whether X is null first. Then it calls itself on X arrow left and on X arrow right. Sooner or later one of those children is null, and we still try to read from it. Here is the symptom. A segfault, the moment the code follows the first null child link and reads data through it. And here is the part people get wrong. That first null link is a leaf's missing child, so it is reached early at the leftmost leaf. It is not deep in the tree. The fix is that every recursive tree function needs the null check as its very first line, so the recursion stops before it dereferences a null child. The fix is one line and it goes first. If X is equal to null, return. That is the base case, and it stops the recursion at an empty spot before we read anything. Only after that check do we print X arrow data. By now we know X is a real node. Then we recurse on the left child and on the right child. Those calls may well receive null, and that is fine now because the very first line handles it. Let us test yourself. We call preorder bad the version with no null check on node 77. 77 is a leaf, so its left child is null. What happens? Pause for a moment before the answer. Here is the answer. It prints 77. Then it calls itself on X arrow left, which is null. That call prints X arrow data straight away, so it reads from a null pointer. That is a segmentation fault. So the base case is not optional. Every leaf's children are null, so every recursive call has to check before it dereferences. And notice the crash comes early at the first leaf, not deep in the tree. Preorder, inorder, and postorder differ by just one line's position. If you move that line by accident, you get the wrong order, not a compile error. This function is called oops. It was meant to be in order. Look at the print line. It prints X arrow data before the left call. That makes this preorder, not in order. The visit happened too early. The left call and the right call come after the print. For in order, the print belongs between them, not before. The symptom is quiet. The output is a valid traversal, just the wrong one. Nothing crashes, so a quick test can miss it. The fix is to compare your code against the pseudocode line by line. Check where the visit sits, not just that every value printed. This is a level order bug. We start by putting root into the queue. So far so good. The queue now holds one node. The loop runs while count is greater than 0, that is, while the queue still has nodes in it. Inside the loop, we take the front node out of the queue and call it X. Then we print X arrow data. That prints the root. And here is the bug. We forgot to add the children to the queue. We never enqueue X arrow left or X arrow right. The symptom is clear once you see it. The program prints only the root. Then the queue is empty, count goes to 0, and the loop stops. The rest of the tree is skipped. There is no crash and no warning. This one is quiet, so a quick test can miss it. The fix is simple. Every DQ must also enqueue that node's non-null children, exactly as in Chapter 7's queue use.